class because I was confused.
No, we didn't.
Well, throw it at me.
It's like
Again, for those of you at home, it's just review day. If you have questions, maybe get them to me real quickly and I can get a response back to you. But you are welcome to work on your own. You're welcome to ask questions. Anything at all, just throw it at me and we'll take a look.
It was expanding binomials, like using the combinations thing, but you can do Pascal's triangle too.
You remember what problem?
Like all of them.
Is this bookwork?
I think it started at 35. It started at 33 or 35.
686. Number
33 or 35.
33.
I also didn't know how to do the, like, I really did.
Yeah, so it says use the binomial theorem to do that. So on number 33, the question was, I'm not going to ask this if that helps you, but this just gave you practice. It said x squared plus y squared to the fourth, but it said use that binomial theorem. Well, the binomial theorem is what we do to find individual terms. So how many terms are there? There's 5, right? Because anytime it's a power, there's going to be one more than the power when you do the expansion. And you can see that when you go to Pascal's triangle. If you were to use Pascal's triangle and not the theorem, you know that on Pascal's triangle, when you get down to the 4 row, it's 1, 4, 6, 4, 1, right? So that's not using the binomial theorem directly. It's kind of doing it indirectly. So directly, you'd be saying, all right, for the first term, K is 0. For the second term, K is 1. For the third term, K is 2, etc., etc. That would be expanding using the binomial theorem, because the binomial theorem is this little formula that we use. And I don't know if you know this, but Pascal's triangle, I know we write 1, 1, 1, 1, 2, 1, but do you know that it's really 1, 1, 1, 1, 2, 1. Have I mentioned this before? 1, 3, 3, 1. If you simplify these, like, you remember what a combination is? Oh my gosh, we didn't do probability. A combination, something like, I'll tell you what, I'll use 8. A combination means 8 factorial over 3 factorial, 8 minus 3 factorial. So all of these things that we've been doing up front on these binomial expansions, those are combinations. Well, all of these numbers up front, this number, this number, this number, those are the elements. That's the 4C0, 4C1, 4C2, 4C3, 4C4. This is Pascal's triangle. But that blows away a lot of people when they initially teach it, because it's a little above your pay grade. When you learned that with Miss Tyree, didn't you? She threw that at you, probably? Yeah, so combinations is above your pay grade maybe a little bit at the time. So they just say, oh, it's 1, 1, 1, 1, 2, 1. They show you the clever pattern about adding the 2 numbers above. But it really is this. And those numbers right there, those are the numbers out in front on the binomial. I mean, those numbers out in front for the binomial theorem. So this is one way to do it if the question said use the binomial theorem. But I'm not going to ask you that on a test. If I told you to expand this, then you could just say, hey, forget that junk. I'm just going to go 1, 4, 6, 4, 1. And then you probably wouldn't have done this. Well, you might have. Remember, you're going to go that number to the 4th, that number to the 3rd, that number to the 2nd, all the way to the 0. And then this number to the 0, this number to the 1st, this number to the 2nd. Do you remember that with the expansions? So that's how I would have expanded it. What you're going to have to do on a test is I'll say, find the 4th term. So when you find the fourth term, you'll just come over here and go, all right, fourth term, can I fit that in? I would just ask you for a certain term, and you'd say, all right, if I want the fourth term, then my k value is 3. You'll go 4 factorial. And if the k value is 3, I plug that there. These have to add to 4. And then you'd simplify. Does that help?
Yes.
So you won't have to, when they say use the binomial theorem, this is the binomial theorem. You're basically using that little formula that you have to come up with certain terms. But there are easier ways to go about an expansion if you understand Pascal's triangle and that it came from the binomial theorem, sort of, yeah.
Also for number 8-1, we had to approximate the decimals. Can you give us one like that long?
It is very doubtful. But let me show you, I know when you're saying doubtful, you don't have to do all of it. For instance, let me give you one that's a little smaller and kind of explain. Like so, let's just say, but I've seen that question in math tournaments a lot. When I say a lot, I mean over the years I've seen it a few times. So let's just say I asked you what is 2.99 to the 7th, and I said accurate to the 100th place. All right, so to 2 decimals. And you look at that and you go, well, that's the same thing as 3 minus 0.01. All right? I'll tell you what. How about this? So if you are expanding, does that make sense? This minus that is that? So if you were expanding this, you would use the 5 row, right? And the 5 row is not, you get all the way down on the triangle to 1, 4, 6, 4, 1, and you got 1, 5, 10, 10, 5, 1. So let's just look at that. So this is 1, 5, 10, 10, 5, 1. And this is why this is easier than you think. Check it out. And it's not easy, but it's easier than you think. So 3 would go here to the 5th, 3 to the 4th, 3 to the 3rd, 3 to the 2nd, 3, no 3. And then here, negative point, and plus, if it's plus minus, what do we do with the signs? Alternate them, and then I don't have to worry about the negative anymore. Plus, minus, plus, minus, plus, minus. And then I can put no 0.01s, 1.01, 2.01, 3.01s, 0.01 to the 4th, 0.01 to the 5th. Now, if I'm only going to 2 decimals, anything that has decimals beyond that, I don't have to worry about. So, like, think about it. If I multiply 0.01 to the 5th, what does that give me? Do y'all remember how to do that? Without writing it all out? You remember like when you learned to multiply stuff like this? You could just ignore the decimals and then count the decimal places up and move it over? So what happens when you multiply 1 times 1 times 1 times 1 times 1? You get 1, but how many decimals is that going to be? 10? So 10 decimals? You really think I have to worry about this decimal here? 1, 2, 3, 4, 5. I don't have to worry about this. I'm ignoring it because it's not going to affect me. What about this one? This ends up being 15 times 1 is 15, but how many decimal places? I'm moving it 8 decimal places. Isn't that irrelevant? What about this one? This is 90. 9 times 10 is 90 times 1. This is 90, but what? How many decimal places? 1, 2, 3, 4, 5, 6. Irrelevant. So a lot of these are irrelevant values because they're just such small decimals, they don't matter when you're only rounding to the hundreds. This one, 27 times 10 is 270. Oh, but how many decimal places? 4. 1, 2, 3, 4. Okay, that's going to matter. So that's a 0.0270. This would be 81 times 5, 405. But how many decimal places? 2, 1, 2. So that's a 4.05. And then this is just 3 to the 5th, or
243.
243. So it turns out I only really had 3 numbers that were relevant here. So when you're thinking about those, whether it's 5 or whether it's 10 or 12, I mean, I'm not going to ask you the 12, but the reality of it is, even if I did, which I won't, but even if I did, most of the numbers are going to be irrelevant, so you can just toss them. And that number is, now you might go, this is always like number 1 on Vestadia's test. Because there's always some poor sap out there, right, that looks through all 25 questions and is like, I can't do this. But man, I can multiply 2.99 by itself 5 times. And sometimes it's like 2.999. So you're subtracting a 0.001, right? And they make it to the 10th. And literally, I have had somebody come up to me. I was like, how'd you do? He goes, I got a 4, man. I got number 1. I'm like, what was number 1? And they show me. I'm like, how'd you do it? Man, I just multiplied it up. It took me 25 minutes. And I'm like, all right, congratulations. But that's the idea. They put it on number 1 because they're thinking there's always somebody who's going to waste all their time and then their score is now irrelevant because they spent all this time. But that being said, if that's something you can do, knock yourself out. But I have given that in the past, but it would probably be more along the lines of this. But you certainly don't want to multiply 2.99 times 2.99 and then take that result and multiply it by itself and then another 2. You wouldn't want to do that. This is so much simpler, right? So 247.077, so it would round to 0.08, right? And it didn't take me more than a couple minutes with this kind of thinking. But that's what you got to start recognizing. That so many of these other decimals are going to be so small, you don't have to worry about it. Yeah?
Or on the review, you were talking about those problems from like the summer review with those formulas. Those involve number 15, 18, 19, and 20. Are those, should we omit those?
15, oh yeah. On the review. What page is this review on?
77.
And number what?
15, 18, 19, and 20.
Oh yeah, we are not doing that. Good question. We can totally do 14, which I'll talk about. Because 14, even though it could be considered one of those, it's also linear. And if it's linear, it's arithmetic, and you can actually sum those. So 14 you should be able to do, because that's arithmetic. But this, I will not ask you to do something like this. This, you could do it, right? I mean, you could write, plug a 1 in, plug a 2 in. It's going to start getting ugly at 9, 8 or 9 or whatever. I'm not going to ask you that because that requires those formulas. So omit 15, omit 18, A, B, C, and D, omit 19 and 20. Yeah, sorry, I missed that. We're not going to do those. I mean, it really was about you testing your formula. And it's honestly, that stuff does show up if we ever did have a tournament. And it'll be unfortunate we'll miss something that's kind of easy like that if you know the formula, but anyway. What else? Anybody else have anything on the review?
Yes.
Okay, so it says, write the series using sigma notation. Let me ask you a question before I do number 10. I explained this to my my Algebra 2 kids just yesterday. They're doing sequences in series also. And I said, what if you had ignore this for 1 second. What if you had a geometric, which this is not, but what if you had a geometric that was this? Right? And I said, give me a formula. Wouldn't you say that the formula for this geometric is the first term times the ratio which is negative 2, to the n minus 1th power. Right? Now I have a question. Could you have also done this? You wouldn't want to do this with the geometric because it's so easy to look at the ratio this way. But could you have done this? Just multiplied by 2 to the n minus 1. And if you think about that, that's going to give you 2, positive 4, positive 8, positive 16, positive 32. And then, to change the signs, do that. Think about it. If I plug a 1 in, 1 minus 1 is 0, negative 1 to the 0 is 1, so it doesn't do anything to that. But if I plug a 2 in, negative 1 to the 2 minus 1 is negative 1 to the first, that's a negative. That changes the sign. If I plug a 3 in, 3 minus 1 is 2, negative 1 squared, it's positive, doesn't change the value. But if I plug a 4 in, 4 minus 1 is 3, negative 1 cubed is negative, changes the sign. And plus, don't you know the math of that? Isn't a times b to the n the same thing as a to the n times b to the n? Isn't that what I just did here? A to that times b to that is a times b to that. Now, you would never want to do this, though, right? But what if it's arithmetic? If it's arithmetic looking, but the signs are changing, couldn't you just basically say, well, I'm just going to ignore the negatives for a second. Just ignore them. And if I ignored them, it'd be really easy to look at that and go, oh, it's just an arithmetic sequence where the first term is 3 and the common difference is 5. So 5n minus 2, wouldn't that work if it was all positive? So look, plug in a 1, you get a 3. Plug in a 2, you get a 10. Plug in a 3, you get a 13. And then if I want the signs to change, what could I do? So I could just tack on to the end a negative 1 to the n minus 1. And then that just changes the signs. Because again, look, if I plug in a 1, 1 minus 1 is 0, negative 1 to the 0 is positive. Doesn't change the sign. But if I plug in a 2, negative 1 to the 2 minus 1 is negative 1 to the first, it's negative, it does change the sign. This is neither arithmetic nor geometric. Unless you look at it like it's two arithmetics, right? All the positives, you're adding 10. All the negatives, you're subtracting 10. But the problem is it didn't ask you to find the sum. It asked you to put it in sigma notation. So I need one sigma notation. So what I'm going to do is find the formula, do a big sigma from 1 to whatever place that is. Now here's where people a lot of times get in trouble. They go, how do I figure out what place that is in? And they go, oh, you use the other formula. So they pull out their other formula, but this is how they go wrong a lot of times. They go, to figure out what place that's in, and this is especially bad when the last term ends up being negative. If the last term ended up being negative, they plug a negative in there. But remember, this is not an arithmetic sequence, is it? It looks like it, but the signs are changing. There isn't a common difference. It's a weird sequence. So if I want to find out what place it's in, I have to pretend that they're all positive. Just pretend, and then use this formula. See, because there's really not a difference. That minus that is negative 11. That minus that's 21. That minus that's negative 31. Like if I really look at the common difference, there isn't one. But if I treat it like it's all positive, then I can treat it like it has a common difference, and I can actually, what is this, 48 plus 1? I can actually solve that for that place. So it's a weird kind of a problem, but I can write it there. You just have to do a little pretending to be able to see it. Does that make sense? But this is how you change the sign if it's not arithmetic or geometric, so you can't actually find a negative ratio to help you out. If it's not, but it's still changing signs, just do this. And what would you do, by the way, if the signs were negative, then positive, negative, then positive? What if it did that? Think about that for 2 seconds. It's all right. Yeah, then you just get rid of the n minus 1. Right? And now when you plug a 1 in, on the first term would be negative, but if I plug a 2 in, it's positive. Right? But on this one, you need that. And by the way, you could use n plus 1. It just needs to be 1 more or 1 less than n to make it go plus minus. What do you think? Anybody else on anything on this you want to ask about? Just feel free to scan it. Pascal, you weren't here 2 seconds ago. We're omitting 15 and 18, 19, 20. And then you won't have to worry about that on the test at all. Or those formulas. And if y'all did do that worksheet, I noticed a couple of y'all at home did it expertly, which is curious to me. Yeah, you do not need to know how to do these kinds of problems, nor do you need to have that worksheet done. We're omitting that completely. What else you got? Anyone? Nope, feeling good?
Could you just work like one quadratic again?
Yeah. Dude, I'm going to leave you number 1 so that you can do it, but I'll just do a different one. Unless I just happen to make one up that is number 1. Okay, so let's just say I had and I say find the 101st term. So first thing you need to do, you don't know that it's quadratic, right? When I first throw it up there. Is it arithmetic? -2, +1, +4? No. Is it geometric? 14 16ths, 15 14ths? No. Is it harmonic? I don't have any idea what the common numerator would be there. And if you ever look at it and you're like, I can't find a common numerator. I mean, I can, but that would be absolutely atrocious. It's not harmonic, okay? I mean, you can try to find a common numerator, but in no place on this earth would a problem I give you be this ugly. And even if it was, your denominators would not be arithmetic in the end. So it's not harmonic. So is it 2 geometrics? No. You go through all, is it strange sum? No. So you go down your list, nothing works, and you finally get to the point where you go, well, is it quadratic? What has to happen on a quadratic? This has to be arithmetic. Is it?
Yes.
Looks arithmetic to me. Looks like I'm adding 3, adding 3, adding 3, adding 3. So I check the box. Great, it's quadratic. So if it's quadratic, what do I need to find the 101st term?
Your formula.
Say it again?
The n squared.
So I have to find that formula, right? The an squared plus the bn plus the c, which means I need those 3 letters. So what's the trick on finding the a value? So 2a is the difference of this little arithmetic thing. So 2a is 3. So a is 3/2. Check. I'm on my way. What else can I find quickly? So the 0 term just happens to be not only the 0 term, but also the c value. And we talked about that in class, right? So how do I find that? I think, well, if I'm adding 3 there, I would subtract 3 there, right? To move that arithmetic back. So what number do I subtract 5 to get 16? 21? So 21 is my C. Great. So now all I got to do is find my B value. Well, if you go back to this formula, the first term was really 16. So if the first term is 16, that means I plug a 1 in for n. So 16 is A plus B plus C. And I already know A and I already know C. So I can solve for B. So 16 is 3/2 plus B plus 21. So if I subtract that, I get a -5. I subtract 1.5, I get a -6/2, I believe. So B is -13/2. And that's my formula. I'll tell you what, I'll make it easier. Make it the 100th term. So what would be the 100th term? 3/2 times 100 squared minus 13/2 times 100 plus 21. So this would be what? 3, 1, 2, 3, 4 over 2 minus 13, 1, 2 zeros over 2. So what is that? 15,650. So whatever 15,021 minus 650 is, and you'd have a calculator, right? Make sure you bring a calculator. So you would be expected to show me the A, show me the B, show me how you found all these letters, get into that. I would be basically looking for this formula, and then for your final answer, which would be 14,371 maybe? Which I would just need to see that you had actually done the math of it and didn't have some miracle, you know. That makes sense? What else? All right. If you change your mind, you know where to find me. Just loitering.